Hello, good day. Yes, in this special class, we'll be looking at this question before us. To find the inverse if A is the matrix 3, 2, minus negative 4, and 5. So we're going to find the procedure for finding the inverse of a 2 by 2 matrix. So here, the first thing to do here is to look at the matrix, the given matrix here. Now, recall that in indices, if you have A times A raised power minus 1, we're going to have A raised power 0, which is equals to 1. In matrix, the typical replica of this is A multiply A inverse must give birth to what we know as the identity matrix. So, and the identity matrix of 2 by 2 matrix here is simply 1, 0, 0, 1. So we see that the major diagonal are just 1, okay, while the other ones are 0. So this is what we're going to use to resolve these questions by transforming this into a pair of simultaneous equations. Now, but in fact, we don't know this inverse. Okay, we could say that let the inverse matrix be a matrix of P Q arrow X. Okay, let the matrix be this. So what we see here is that we are looking for the product. So A times A inverse can simply be written as times A is equal to the identity matrix. Now we know that the inverse matrix, okay, is this. So we can transform this to P Q arrow X times the matrix A, which is 3, 2, negative 4, and 5, is equal to the matrix 1, 0, 0, 1. So from here, we will try and find the numerical values for P, Q, R, X, which is the identity matrix here. Now, what do we do here? Now, for the multiplication of two matrices, okay, the rule says that each of this column, each of this row, this is row and this is column. Okay, this is row and this is another column. This is row, from here is column, this is column, and this is row. It says that each of this row here have to multiply each of the column, and the result obtained is equivalent to the matrix on the right hand side. That is equality of matrix. So here, this is P times 3, this gives 3P, then Q plus Q times minus 4, that gives negative 4Q, because plus minus is negative. Then let's form this matrix again, PQ multiplying this column. Okay, remember when I say PQ multiply the first column here, the corresponding result here is equal to 1. So that is what we must do first, equals to 1. This, assuming this is equation 1. Then the same PQ now we also multiply this column, this row, and this column. So that gives 2P, P times 2, 2P, then Q times 5, that gives plus 5Q. That will give the corresponding value, the element here, which is 0. This is equation 2. Now, similarly, we still have to come to this row. We multiply these two columns to form another two pair of equation. And in this case, arrow times 3, that gives 3R. The arrow times minus, x times minus 4, that will give us minus 4x. Remember, this will be equal to this. This is 0. Let's label this as equation 3. Then similarly, this row will also multiply this column. Just have a 2r plus 5x. Here, this one is correspond to this is equals to 1. Is equation 4. So all we need to do now is just for us to resolve and get the numerical value of PQRS by solving this 4 pair of simultaneous equation. Okay. Now let's resolve this first. Resolving this means let's first of all eliminate P. Okay, let's use elimination method to do this. If we are eliminating P here, it means that we take the coefficient of P in equation 2 to multiply equation 1, and the coefficient of P in equation 1 to multiply equation 2. So in that case, we are saying equation 1 times 2 and equation 2 times 3. So for us to obtain this, now once that is done, we will see that we have this becomes 6p, 2 times 3p, 6p, 2 times minus 4q, that is negative 8q. Then 2 multiply 1, this 1, this becomes equation 5. So similarly, equation 2 multiplied by 3, I mean 3 times 2p, that also gives 6p. 3 times plus 5q, that gives 15q. 3 times 0, that gives 0. This is equation 6. Okay, this equation 6. Now, because we are trying to eliminate p, we subtract equation 6 from 5. So because the coefficient of sign here is plus plus, so we're going to put negative here, and negative eliminates p here. So this negative sign here will affect this. So minus 8q minus plus is minus 15, and that is 23, negative 23q. So 2 minus 0, 0. So 2 minus 0 is exactly 2. So q, to obtain the value of q, divide both sides by 2, and this gives a negative 2 over 23. Then we can easily obtain the value of p now by substituting the value of q into either equation 1 or equation 2. So let's put it in equation 2. So 2p plus 5 into q, and q is minus 2 over 23 equals to 0. So if we do this, this becomes 2p minus 10 over 23 equals to 0. So we'll move this one to the right hand side, because this is negative become positive. So 2p is equals to 10 over 23. To obtain the value of p, multiply both sides by half. Okay, multiply both sides by half, because we need to remove the coefficient of p here, so that p is equals to 5 over 23. So we have obtained the value of p and q respectively as this. Now let's shift our attention to equation 3 and equation 4. 3r minus 4x equals to 0. 2r plus 5x is equals to 1. So let's also eliminate r here. So multiply equation 3 by 2. 3 equation 3 times 2, and equation 4 times 3. So if we do that, eventually we will also obtain an equation that will be equation 7 and 8, which is 6r minus 8s is equals to 0, because by the time to multiply the whole of this, everything here, this is 6r minus x, 0 times 2 is 0. This becomes equation 7. Then equation 4, we said to multiply by 3. This will give 6r to 6r plus 15x is equals to 3, because 3 multiply 1 is 3. This gives equation 8. So let's eliminate r. So 6r minus 6r is off. Minus 8x minus plus is minus here. So here become negative 23x. Now 0 minus 3, that gives a negative 3. Okay, so x here is equal to negative 3 divide 23, negative 23. So we're dividing both sides by negative 23, negative 23. So x is equal to 3 over 23. So here we have to go back to the matrix, the inverse matrix, which is defined by PQRX, and substitute all the respective values so obtained. So that means A inverse, we look at P is 5, so P is 5 over 23, and Q is negative 2 over 23, and R is, we've not obtained the value of R, so we'll just obtain the value of X. So quickly, let's find the value of R of X, since we have obtained the value of X. So we'll put the value of X into equation 3, which is 3R minus 4X. So, and X is 3 over 23 is equals to 0. So here we have a 3R minus 12 over 23 is equals to 0. So 3R is equals to, if we move negative to the right hand side, become positive 12 over 23. So arrow here, to get arrow, multiply both sides by 1/3, both sides by 1/3, and this become 4 over 23. So with that, we can now recall that initially we've defined that the inverse matrix is made up of PQRX. So we substitute all the values to obtain. For P, the value is 5 over 23. Then for Q, the value is negative 2 over 23. For R, the value is 4 over 23. And for X, the value is 3 over 23. So we could see that something is common here. So we can either leave it like this, or we pull the 1 over 23 out, which is 1 over 23, which is common, then into the matrix 5, negative 2, then 4, negative 3. So this is the identity matrix associated with this matrix. You could observe clearly here that just this value here, the interchange, while this one they remain, but they are multiplied by a negative sign. Okay, so this is how to obtain the inverse of the 2 by 2 matrix. In my next class, I'm going to provide a comprehensive proof why it is like this. But please, if you find this video very useful, all you could help me do is like, comment, subscribe, and also follow my Facebook page. See you in my next virtual class.